So welcome and thanks everyone for joining us today for this panel discussion. My name is Hector Barresi. I'm an industrial automation expert with 20 years of experience creating and commercializing innovative solutions and services using emerging technologies like wireless, industrial wireless, IoT, and AI, artificial intelligence with GE, Honeywell, Danaher, and IDEX. And I would like to welcome today to this panel. First of all, please familiarize yourself with the webinar tool. Use the chat to tell us where you are located. Meantime, some upcoming dates for future IIoT events to be aware of. Intelligent Secure Edge for Smart Cities on May 26th. IIoT World Energy Day on June 8th. IIoT World Cybersecurity Day on October 26th. We will be taking questions at the end, so please post them into the Q&A area on your screen, not on the chat. Please use the Q&A area for the questions, and we will be taking some questions at the end. The track will run for about 55 minutes, and we will get you out of here on time. A word about our sponsors, which obviously it wouldn't be possible to run this conference without our sponsors. So thank you, Hitachi Vantara, Hive MQ, Siemens, Fortinet, Keyfactor, EMQ Technologies, K-Factory, Ovesi MDT, Trend Micro, Faircom, Nozomi Networks, Limby CMMS, ADALS, and Raven. And a few words about the IIoT World. IIoT World is the leading authority in industrial IoT. It is a digital media outlet bringing the latest industrial Internet of Things, virtual conferences, and content to a global community of more than 279 decision makers around the world. IIoT World focuses on delivering daily insights on the industrial Internet of Things across multiple verticals, and online it curates a series of virtual events, some of which I've just mentioned before, including the IIoT World Days, which draw thousands of delegates. Now I'd like to introduce the speakers and the topic. The topic for today is how to successfully scale your industrial IoT initiatives leveraging artificial intelligence. This is a topic I'm very passionate about because the analysts talk about the $1.5 trillion market size by 2030, but that starts with growing, scaling up small projects and pilots that are happening right now. So I'm really interested to hear from our panelists how we're going to get to the $1.5 trillion by 2030. About our speakers, we have today Dr. Paul Turner. He's a recognized subject matter expert and industry leader in Industry 4.0 applications and advanced analytics. He brings 25 years of experience in the manufacturing space to his role as COO at Raven. Prior to joining Raven, Paul held several roles with Shell, AspenTech, Wipro, Ernst Young, and Stanley Black & Decker. Welcome, Paul.
Thank you.
We have also Gary Chandler, he's the Chief Technology Officer at QIO Technologies. He uses his deep domain expertise to unlock customer value through advanced analytics and AI-infused software. He's responsible for all commercial aspects of software development. Gary joined QIO from Rolls-Royce after 25 years developing real-time safety-critical control systems for aero engines. Welcome, Gary.
Thank you.
We also have Srinivas Kupa. He is the Chief Strategy Officer at Symphony AI Industrial. He is responsible for overall business strategy, go-to-market, pre-sales, and product packaging. Srinivas has 2 decades of experience working in digital manufacturing, covering product lifecycle management, manufacturing operations, connected asset management, and asset service lifecycle. Welcome, Srinivas.
Thank you so much, Hector.
And Kerry Ware, using his hardware and software engineering background, Kerry is pre-sales engineer at EMQ. Gary focuses on helping customers to explore the many advantages of EMQ IoT solutions. He has worked with customers in a wide range of industries, including telecommunications, automotive, industrial controls, and aerospace and defense. Welcome, Carrie.
Thank you.
So, attendees, now please remember to type your questions during the discussion as we progress through the panel, and we will address it at the end of the conversation, the discussion. So now let's get to the topic, which is how to successfully scale your industrial IoT initiatives leveraging artificial intelligence. Like I said, I'm very passionate about this topic. I want to learn more from the panelists today. So I'm going to start with Carrie. Carrie, you may have heard the expression IIoT pilot trap, meaning companies that seem incapable to move beyond that pilot phase. So what do you think? How do we align business, organization, technology to capture value at scale faster, and we avoid or we escape this pilot trap? What do you think?
Thank you. Yeah, there's several things you can do to avoid the pilot trap, i.e. that's where the pilot's done, but nothing ever is implemented. So the best way to ensure success is a goal-focused iterative approach. In this approach, business and organization provide the goals and technology provides the tools to achieve them. So with this goal-focused iterative approach, you plan big and implement small. And what I mean by plan big is you want to do your upfront planning to define the clear objectives, the clear measurable goals, whether it's to reduce downtime, improve quality, optimize operations, etc. So you want to define your metrics to success. And ideally, you want to identify the areas of greatest impact. So you may also want to identify the low-hanging fruit in order to get some quick success. But the most focus should be on the areas of greatest impact. And you want to make sure you do the right pilot. So make sure the goals are aligned with the business's 3 to 5 year plan so you know you're on the right track. So with alignment to the business plan's goals and objectives, it allows you to attract the right stakeholders across the organization. So it's important that you have stakeholders from both upper management and end users and operators. So without commitment from the upper management and end users, the pilot may fail because of lack of resources or lack of acceptance by the end users. So keep in mind that the stakeholders may actually be negative. So there could be people who are actually resistant to adoption. So you want to make sure you have a plan to take these into consideration. And then you want to implement small. And when I mean implement small, I mean working iteratively in short few week cycles where you plan, implement, and evaluate at each cycle. And this lets you use what you've learned in one cycle to better plan for the next. So it allows you to be flexible. So even though you may have certain plans at the beginning, it allows you to adopt along the way. Yeah. So the other thing that's important is you want to make sure you have a complete cycle all the way down to the end users on the shop floor. So you want to always deliver small incremental value to the operators and get their valuable feedback. So this motivates the end users and makes them part of the solution. So the plan big, implement small works for the rollout too. So basically it's the same process regardless of scale. So the key message is a goal-focused iterative approach with key stakeholder involvement avoids the pilot trap.
Right, right. And keeping the customer in mind, right, at the end of the day. So
yeah,
think big, execute in pieces, have early successes. But you also talked about, obviously, the alignment of the organization. And that sometimes it's really not about the technology, but about the people. So how you get there. So maybe I would ask Paul, how do we drive change management, right? And the engagement, because you need everybody all the way from the shop floor to the other departments, engineering, operations. Paul, what do you think? How we get there? Because people are key. Engagement is important.
Absolutely. So we often talk about change management and how important it is to technology adoption on the shop floor. But as Gary says, all too often the technology projects pilots fail due to a lack of engagement and sustained adoption by those operations teams. Many factors can influence whether technology gets adopted or not. For example, system reliability. Teams that are used to working with pen, paper, clipboards, printouts of Excel spreadsheets may be quite skeptical of relying too heavily on digital infrastructure that may or may not be reliable. Operations expect 100% availability of any system that they, particularly what they require for their daily work. And it only takes a couple of outages when data is needed and it not being there for those teams to then quickly revert back to traditional non-digital methods. So system reliability has to be a high priority metric for any technology solution in manufacturing. And then also, we have to make life easier for the operations teams. Shop floor workers expect technology to make their life easier. Often, though, we actually need to engage operators in order to make this happen. And we have to earn the right to do that. So, for example, if a machine or asset goes down, and we need to know why it's gone down, so we need to label the downtime reason for context, then we may have to ask the operator to input this information. So now we're actually putting a burden on the operator. If they're looking after dozens of machines and they're monitoring sort of hundreds of stoppages per day, then that's potentially a significant demand on an operator's time. And that's a recipe for them to disengage, pay lip service to the solutions, which results in insufficiently labeled data or even incorrectly labeled data. So we need to use, the way we get around this is we need to leverage technology in order to reduce that burden. And the way that we do that is threefold. Firstly, we can use techniques like AI and machine learning to automate those processes. So for example, if after a changeover there's a period of instability, microstops, then algorithms can spot those patterns and automatically label the data, allowing the operator to focus on the task in hand, which is to get the machine back up and running again. Secondly, if we do have to ask the operators to input some information, we have to make it as easy for them to do that as possible. So one touch, maybe two. The operators are working in these sort of often greasy, oily environments. They're wearing gloves. And so the usability of the system is key to get that engagement. And then finally, if the operator does input information, then they have to get something back in return. For example, if the machine's down because, say, it's waiting for material, then if the operator does select a downtime reason to give us that context and feedback for the advanced AI and other applications, then maybe the system could alert the materials handling department to tell them that there's, that they're waiting for material. So there's a win-win situation. So the message here from a change management perspective is we need to get into the heads of operators and understand their psychological needs that they have in order for them to engage effectively with technology and then have active participation in that digital transformation journey.
Yeah, no, you're absolutely right. You have a good message here. I read I think it was a McKinsey report recently that you may have the whole floor operations and all the different, so to speak, soldiers ready to change, but sometimes it's at the top management that there is some resistance to adoption. And so it's not about technology, it's really more about the people, right? So Gary, maybe I want to tap on you, what's your opinion about, everybody's excited about change, but could we be facing potentially some level of resistance to adoption somewhere throughout the organization, Gary?
Yeah, I mean, I think we do see that, and fundamentally, we all know that change is hard, and really what we have to think about is when it impacts individual machine operators. I really think that we as technology providers, along with those leaders on the shop floor, we have a high responsibility to be very sensitive to the needs of those operators and really help them to adopt the new technologies, as Paul said. We do see quite a difference between successful pilots and then the scale up, and it's interesting just to sort of reflect on those a little bit. Where we see the success with technology deployments We often find that's where we've really been able to demonstrate we have assisted individuals and made them even more successful than they already are. And being able to demonstrate that the AI delivers a real benefit for them personally. Maybe it's reinforcing the decisions they're making, or challenging any bias that may have developed. But it's good to position the AI as a coach or a mentor working with the individual, rather than oftentimes, it can be positioned that it's trying to replace them or, automate them out of the process. The difference in the pilot environment, I think, really is that we often see operators in that environment who are already engaged and already eager to try new things in the pursuit of better performance. Often those operators, they're almost pre-selected to be part of the pilot because of their interest in trying new things, and also their ability to help objectively validate the business value proposition. So pilots often tend to go quite well because you've got that level of buy-in. But when you try and scale out, as you say, Hector, not everybody in the organization feels the same way. And, real resistance to adoption of AI can increase across the organization as you scale out from that center. Quite often you find that operators and satellite sites are less informed than those that were involved in the pilot. And anyways, they're more concerned on the impact the new technology may have on them personally. So I think for many industries, it's really a culture and a communication challenge, and it needs to be a key consideration up front in the whole planning process.
Yeah, I agree. You mentioned that obviously the pilot is kind of a safe environment where you are allowed to play a little bit, you can fail, you can try again, adjust. So the pilot environment, and going back to the pilot trap, right, is a playground, and then you can scale up. Now you get serious, and you're talking serious money, time, investment, and bigger risks. But I like what you said about the individuals that participate in the pilot that are kind of maybe pre-selected, or maybe not, but they could be the ambassadors. They could be the people that they can tell the rest of the organization, hey, we did it, it worked, trust us, right? So maybe we can use the people that worked on the pilot to be the ambassadors to the rest of the organization. Because the reality is that some companies, some industries seem to be, gaining speed faster and obtaining value from these pilots and scaling up faster than others. So I'm going to tap on Srinivas. Why do you think that is, that some industries or companies are scaling up faster, breaking the pilot trap and really getting into large scale projects faster? Srinivas?
Yeah, thanks for the question, Hector. I think I agree with all the concerns that were raised, but like you said, right, on the other hand, that we see companies adopting AI, adopting IoT, and getting significant benefits out of it. Some of the things that I've seen that the companies that do successfully are the ones that mitigate all the concerns that my panelists have raised, right? I'll be very specific in a few areas. They do a better strategy and a better execution. That is at a very high level. What I mean by that is when you define a pilot program or multiple pilot programs, it's very important for the leadership at certain levels to be able to identify what the key goals are. Typically, the pilot program is just to show shining thing out there and then kind of move on. But if you really draw the goals in a more strategic way, either at the plant level or a division level or a subdivision level or even enterprise level, and use that as a guiding principle to help pilots succeed. That's one. The second thing the companies do better is the pilots usually are anomalous, right? One is either it's the best case scenario or the worst case scenario. That doesn't translate well into the overall challenges that the company is facing at large or at multiple plants. The third thing that I have seen companies do better is what I call as decentralize and govern. Because if you look at plants, if you look at companies, or if you look at the business side of things, I would draw a broad picture of companies are either looking for process-based efficiencies or data-driven efficiencies. If I'm a plant manager or I lead a bunch of plants, I would say I have a few processes which I, by and large, know that they're inefficient. Let me take the localization problem and try to build efficiencies along the way, and then maybe connect these inefficiencies and improve upon over time. That's more process-driven, where you'll start with automation and then employ the AI-based improvement as a continuous cycle. If you're more data-driven, now your steps should be more to get the connectivity going, get the data sourced, have the technology and the know-how that builds on that side, and kind of look at the outcomes from that side. Either of the approaches that you take, when the companies are leading with what I call as a decentralized leadership in terms of letting the plant managers, letting the subdivision leaders drive the goals, but then also govern it a little bit of a higher levels of hierarchy in terms of calculating and responding to the value that comes out, that's where the companies are getting more successful. I mean, semiconductors, for example, right? I mean, for them, it's a necessity, and necessity is leading them to make all these changes, and people just fall in line to deliver on it. Pharmaceuticals, biologics. I've been tracking the biologics industry, which is growing heavily since that COVID breakout, where people want to have this optimized cell culture and generation and so on. And I'm looking at it, how massively the whole manufacturing life cycle is transforming. People are kind of rallying behind it because they identify the problem, they identify either it's a process-driven efficiency they want or data-driven, and be able to employ these things. And then over time, apply the required scalability, because the goals came from top down, but given enough decentralized power. And then they have the right set of skills and technology being adopted right around it. And then the third thing that they're doing right is have a mechanism to track the output and be able to take a more continuous approach to improvisation. One last point I want to touch on is to improve the efficiencies of the manufacturing operations using IoT and AI. It's also important for how the input and output from a manufacturing shop floor works into the shipping area, supply chain, ERP systems which track the procurement. That part of it, all companies just don't look at it when they do the POC. They look at it as a siloed problem, and that doesn't scale. Companies who do the otherwise are succeeding.
Yeah, that was a great summary. One of the takeaways for me, I think, was looks like when the problem or the goal is bigger than the rest of everything, the barriers and the resistance to change, those industries or those companies, semiconductor, pharma, where the goal is big and the opportunity is big, they just move on because it's bigger than themselves. So that for me was an interesting takeaway. I read about some other barriers to adoption and growth, which really more about the model that some companies adopt. One could be, let's go for standardization and scale. Others go versus flexibility and towards versus flexibility and customization. So, and they cannot decide, shall we be standard and scale fast, or shall we kind of get this thing flexible, customizable, and that dilemma kind of gets them stuck. They cannot really decide, and that's why they cannot leave the pilot trap and get involved in these processes. There is no clarity how to move on. So I'm going to tap on Paul for this. What's your opinion in this area? How do we determine what's the best route to success? Standardization and scale, or flexibility and customization? Any ideas, any suggestions?
Yeah, so Readiness talks about the centralized, decentralized dilemma, but I agree. The standardization versus customization dilemma is another sort of big barrier to scale, and we need to get the balance right. So, as I mentioned earlier, change management requires us to empathize with end users. Now, in many factories, that can create a whole list of bespoke, customized requirements in order to meet that particular factory's needs. And rarely are two factories the same. And so we probably all agree that a one-size-fits-all approach doesn't work, even though we've probably tried many times to make it work. So the challenge here, though, is that if we allow a technology solution to place too much emphasis on individual requirements at each factory, then either it won't scale because it's too bespoke, or it evolves to become this sort of unsupportable monolithic solution. And then on the flip side, in order to scale at speed across an enterprise, a solution has to have some level of standardization. One of the reasons many pilots fail to scale is that they have been too heavily customized to an individual plant's needs, and the cost of replicating that level of customization across the organization becomes exorbitant. So what's the solution to that? Well, clearly some sort of hybrid approach is needed. And what I've been pushing for is effectively a standardized core inside an open ecosystem that allows integration with other tools and other suppliers, with each supplier playing to their strengths in a best of breed Industry 4 architecture. So this may mean having a standard method of how you acquire the data from different source systems, a standard way of how you store and access that data through standard data models, schemas, queries, and APIs. And even the architecture may have a standardized way of adding context to data labeling, as I mentioned earlier. However, once a plant has that data, the way they use that data from, say, a reporting perspective or analytics or integration into their daily standard work, then at that point, factories can leverage tools that are specifically designed for customization and citizens development, such as the low no coding platforms that are out there, which can be layered on top of a standardized core in order to combine sufficient standardization for scale, but with enough flexibility to customize to an individual plant's needs. And this may be a slightly controversial statement, but the message here is that, you know, my belief is that no one company can deliver in 4 on their own. The end-to-end Industry 4 solution providers will struggle, and companies that rely too heavily on a single provider or take a siloed approach to their IT/OT lean technology initiatives will probably spend, you know, large amounts of money, but will struggle to make progress to sort of scale and have a truly digitally transformed enterprise. My message is that requires a partnership ecosystem.
Yeah. I guess being conscious that you know, even a successful pilot doesn't grant a successful large-scale project. Companies need to be ready to adjust and to improvise. But the word partnership resonates very much with me as well. No one company can do this alone. Going back to standardization versus bespoke, I wonder if there is some areas where maybe we can standardize more on the connecting side around sensors and machines versus more customized use of data. So maybe I'm going to tap on here on Gary. Gary, what's your opinion on how, you know, the connect side of a full-scale IoT project should be analyzed, executed, and assessed? And is technology helping us now that we have, let's say, 5G? And so can you tell us about the connect side of an IoT, a full-scale IoT project?
Yeah, I mean, I think the first thing to say really is there's no doubt in my mind that that making the physical connections to machines and sensors is the biggest hurdle for a full-scale IoT project. If it was easy for a business to do, or there was a really compelling reason for them to do it, then they would probably have done it already. You know, in the pilot deployment, what we do is we demonstrate the compelling reason. I mean, that's the whole point of doing the pilot. We show a client business value in their environment with their data, and we often do that with data that they have already collected. So you know, we can move quickly and we can show that compelling reason. However, that still does leave the question of how easy it is to make the connections when it comes to scale up. And it can be hard in an organization to identify who's got the skills or the time to go around and make all those connections that may need to be made. Again, I just contrast that with the pilot environment just to emphasize it. It's generally quite straightforward in the pilot project to connect to equipment in that environment. Typically, the scope of the pilot is such that the variety of different connections required is small. We'll only connect to a limited number of PLCs or SCADA systems or historians, whatever. And we might add a few new sensors into the mix, but essentially, the scope is really well controlled, and the requirement for capital investment and disruption to production, that can be kept to an absolute minimum in that pilot environment, and that lets everything progress quite quickly. But the connect workload can quickly become too big a task for organizations in scale up who just don't have the capabilities within their teams to manage all the connection variants that can be found as the opportunity scales. As Paul said, no two factories are the same, even though you think there's identical machines, across those factories. They've had maintenance carried out. There's been changes to them over the years, and that all contributes to the variation that you can find when you actually go and try and make those physical connections. And I think as technology providers, we really need to do a better job of helping those organizations solve this step, and not only just make that connection, but also help them find an ongoing service solution that's going to work for them over the next 5 years, 10 years, and maintain those connections. Now, you mentioned about new technology, Hector, and I think the good news for everybody here is that we are seeing some good tailwinds in this area. Firstly, Srinivas mentioned the pandemic, and what we see is it really does seem to have had a positive effect of accelerating the digital journey of many organizations as they had to adopt to remote working. And in that remote working, they had to make data lakes available across their remote organizations. So some of them have actually gone on and made those connections and made that data available. And those company-wide initiatives, we see them acting as incredibly powerful accelerators to scale up. That's a real good indicator for us when we find that in an organization. Secondly, you mentioned 5G, Hector, and really the emergence of those new technologies such as 5G. They're going to allow companies to establish secure networks of connectivity with minimum disruption to their existing operations in a much easier and more affordable way than they ever could before. There is now a reliable and affordable wireless alternative to having to rip and replace legacy hardwired OT networks. So I think 5G will be a key technology to help with phase scale up. And the key thing is ensuring that business value is delivered in phase with the capital investment of that connecting technology.
That's right. Thanks for your opinion, Gary. Here, I have a follow-up question, which is really about, obviously, the purpose of IIoT and AI is to use the power of artificial intelligence to get us results, analysis, and ultimately call to actions that are better than we've done in the past. And that's why we need a bunch of data, lots of data. And related to that is the connect, because we connect to sensors, we connect to machines, we connect to the plant. Obviously, for some reasons, we need the data, we need relevant data. The question is, two questions, I think. One is, do we need time for that? Because sometimes a full-scale project needs maybe months or years of data before they can really make sense through an AI algorithm. But second is, isn't there a risk to maybe get spoiled and add too many connections, because we think that now we have the power, and so we get kind of spoiled. We say, okay, AI can handle all this, but to your point before, now we have to wire all this or to connect via wireless. So are we really now into the kind of collect trap that we need to collect too much data and that we need a lot of time before AI can produce really useful results? What's your opinion, Gary?
Yeah, so, well, I mean, I feel that once the equipment is connected, as you said, collecting of the data isn't really that hard. We've got the technology to do that. But Hector, you're right to highlight the need to collect enough relevant data. That's what makes the AI analysis and correlations accurate and meaningful. But that doesn't necessarily mean collecting huge volumes of data at high frequencies over long periods of time. You don't need to do that to get value. The key really is to understand the use case, what problem you're trying to solve, and therefore, what characteristics are required of the data in order to build a good AI model that will deliver business value. I mean, personally, I've seen significant business value delivered using as little as 10 parameters collected daily from a single factory over a period of a few weeks. I've also seen business value delivered by using sub-millisecond data collected over a period of just a few seconds. Now, two very different use cases, but they have both delivered significant business value. So the challenge is, how do you think about that data? How do you decide what frequency is needed, to solve a problem? And again, I think there's a bit of good news here is that generally, I find you can just start with what you already have. I find it's better to look at what data is easily available and build a return on investment model from that as a starting point. If you then find there's not enough data or it's not captured at a high enough sample rate, having that ROI model helps to justify the investment in improving the data collection against the additional business value that it may or may not deliver. Now, just really lastly, as an industrial engineer, I'm always going to say that more data at higher frequencies will result in better AI models. But I do also recognize that requiring high frequency data from hundreds of vibration sensors, for example, that can put significant cost challenges and hardware requirements on the architecture. And I would want to ensure there was significant ROI before making that investment in time and effort. The great thing, as you say, is today, IoT, we're not really limited in the volume or the velocity of data we can collect and process, certainly not from a technology standpoint.
Yeah, that's why I talk about getting spoiled sometimes.
Exactly, but there are those use cases that do require us to collect large amounts of data from large fleets of assets, and that data can become huge very quickly. But if that's what is required to solve the problem, then the good news is the technology is available to handle that.
Yes. Let me ask Gary. Gary, what do you think about Gary's comments on data and the use of data, the value of data? Gary, what do you think? How do we resolve this? Because what would be the best architecture really for collecting data, factory equipment? Any opinions?
Yeah, choosing the right architecture up front is a determining factor of whether you're able to scale your implementation or not. So first of all, point-to-point equipment interconnection doesn't scale because the vast number of connections and the development time in creating the interfaces. So you want to choose an infrastructure that will handle your needs as your business grows. So maybe it's 1,000 assets today or 100 million assets tomorrow. So it is important to choose high performance, high availability products for scalability. So I think the best architecture for scalability is a message broker-based architecture using the publish-subscribe model. So this message broker architecture has many benefits. So number one is that the connected equipment is isolated. So there's no direct connection between the connected equipment. And this allows all the factory equipment to publish to a central location and then forward the data to the cloud database and of course the AI. But now AI has access to all the factory equipment data. And this message broker architecture also simplifies the interconnection of equipment. So there's only one interface regardless of the amount of equipment. So it scales quite nicely. And also the interconnected factory equipment can share data amongst each other. So for instance, the production planning software can get the downtime directly from the equipment itself. And the broker also provides a single source of truth for all of the factory data instead of having silos of data spread amongst all the equipment at the plant. So it's flexible and it allows for adding new equipment without disturbing the existing infrastructure. And it's open source, open architecture, which avoids vendor lock-in. And the other, what's other interesting is that the equipment can publish data only when it's changed. It only needs to publish data only when the data change.
Do not overload the network necessarily, right? Yeah.
Right. There's no need for polling, and so it's more effective use of the bandwidth. It's also lightweight. So the key message is a high reliable, high available message broker-based solution is the best solution for scalability.
Thank you, Gary. Let me get, now that we talk about data, about collecting and connecting, maybe getting into practical application. I want to tap on Sriniva's, all this data, right, that we have, and calculation, analytics power. How do we reimagine in a practical application, right, the manufacturing functions to enable a progressive digitalization, journey, I would say, towards flexible manufacturing plants?
Yep, flexible manufacturing, lights off manufacturing. This is really taking the next generation aspect of it. I'll answer this from the business side, but I'll touch on what Paul said and Gary said, which I totally agree with, and so with Gary as well. Today, we are known to know the systems as systems of record, the MES system, the ERP, call them systems of record. And what Paul touched on about that low code capability on top that helps customers in our plants be variable for need, those I call them as systems of transformation, right? And then where we need to go next is the systems of intelligence, I would say. Systems of intelligence mean, it does not mean collecting a whole lot of data and applying a whole bunch of AI algorithms on top of it to generate insights, right? I was talking to a CIO who manages multiple plants under him, and he said every region of his plants generate close to several terabytes of data every day, and he doesn't know what to do with it, right? And that's not a good problem to be challenged with, because now not only do you not know what to do with the data, but now you have the storage costs and other things. So the problem is not architectural or technical in my nature, it's more business driven. So what are you trying to improve is a question that need to be properly answered at various levels of the organization, right? Now, if you zoom in at a plant level, what do you have? You have an asset or multiple assets. You have the workers, the human being. You have the processes that drive and bring the finished product to the work in process. And then you have the material itself, the material that is raw material turning the finished products. In each of these areas, at the plant level and the multi-plant level, people should draw out and say, what am I trying to improve? Number one, for example, the worker, I want to reduce the amount of repeatable work on my worker, and I need to make him be able to make decisions as he's walking around. So give him connectivity, solve the connectivity problem, solve the problem for him to be productive as he's mobile. Don't go for completely AI-driven approach right away. That's too much. Now, the asset part of it, asset efficiency, knowing the asset's value, the asset's capabilities, where it is in its depreciation, what is the attributes that it is pushing in and out, and what kind of data you can pull in to improve the efficiency of the asset. Yeah, absolutely. You got to look at anomaly detection and so on and so forth. Some companies, what they miss is they look at 4 or 5 assets or work cells that make up the line and say, I improved each one of my assets. I have connected them. I've been analyzing them. I don't have to do maintenance more often, but my efficiency of the process end-to-end is not improving. Why? Because you never really connected the dots and looked at the end-to-end, either it's a batch manufacturing or it's a process-driven manufacturing or a single discrete object. You have not looked at the end-to-end cycles, looked at the takt times, cycle times, and found and look at all these attributes to determine what is your optimal set point configuration. So that is an area where you can apply AI quite efficiently and then kind of scale it from line to line, plant to plant. That information can go across even with the variability in place. So coming back to the point you're making, the technology is certainly a challenge because as you go from POCs to a scale, obviously the technology has to scale. The data need to be brought in. Some are paper-based, some are structured, unstructured. But I still believe the business side of it is the key, where we identify at the organizational leadership level, the systems of intelligence is what the future is that will enable them to go into what I call as the flexible or composable or modularized plants. In other words, lights off plants, right? You turn off the lights, go home, nobody's in the office or in the plant, and the manufacturing is still going on. If that's the North Star you're going with, identify your business problems for each of the entities that play into the plant, what kind of step-by-step improvements that you want to bring in, not just go after the data and apply a huge technology behind it or a hyperscaler and then a whole data lake. Yes, that you should do in addressing the business problem that you are trying to solve at scale. That's my take.
Yeah, absolutely. No, I fully agree with you. But again, we're coming back to what's the purpose, what's the what are we trying to accomplish here, and that should be the driver behind this effort, right? We are reaching the point of the Q&A, but I would like to maybe in the last 60 seconds, we talk a lot about no one company can do this together. We need partnerships, more than one supplier and services. So Kerry, maybe in 60 seconds or less, what your or maybe Paul. Paul, what's your thought about co-opetition, meaning really different competitors working together to help a company scale up from a pilot into a large-scale IIoT project? Paul?
Yeah. So my feelings on that are, we have to move away from, these competitive tenders for digital transformation that expect a single vendor or consultancy firm to deliver on all the promises of Industry 4. That's where we need to, and the partner ecosystem, as I mentioned now, however much that makes logical sense, that's actually a seismic shift in the current state of play and many barriers to overcome to establish that. We've currently got IT companies wanting to go into the OT space and vice versa. We have consultancy companies creating their own SaaS solutions, which paradigm shift for them. And we have technology companies trying to be everything to everyone, and it can get quite messy. However, signs are that some of the forward-thinking consultancy firms are looking at the future and seeing that the partnership model is going to be key to effectively scale in a manner that's feasible and provides maximum return on investment. And we at Raven are looking forward to be part of those ecosystems.
Yeah, absolutely, great point. So this concludes with 8:46 Central Time here, concludes the panel discussion. We're going to address some of the Q&A. We have really a flurry of questions. Thank you so much, the audience. So I'm gonna use about 10 minutes for addressing Q&A online, and others will be responded offline. And again, it's a lot of questions. Thank you for that. The first question is, how has artificial intelligence been used to solve key challenges in manufacturing with proven ROI? I think the key word here is proving. So I wonder, Kerry, would you like to take that one? Examples of?
Yeah, maybe some of the others may want to take that one.
Okay.
Yeah, I can take that, right? I mean, I have, I cannot name the companies, but of course, the idea of achieving a golden batch is something we were able to achieve for our customer. Okay. Of course, have we done it at scale? Can it be done at multi-plants? Of course, it's a debate that we went through right now. But if you look at a line is well instrumented with the assets, and you want to keep it closed, and you don't want a human coming in and contaminating it for whatever reason. And you want to identify the golden batch based on what are the set points that you need to set on the assets, what kind of the material that you need to move, reduce the waste. Once you draw these parameters in, how do you identify it? We have been able to do it successfully. The other example, which is very generic, and everybody might have done it, is, but it's very simple, right? AI vision. So image-based analysis or even vision-based analysis, a little bit more advanced using CNN and otherwise, really helps companies identify the defects, the dents, the issues in high-value assets like the wafers in the semiconductor manufacturing. Identifying a wafer defect manually is a huge challenge because you end up throwing away more things that are not defects by that visual view, whereas a trained model can efficiently do it, and it's proven. So, and you have seen a lot of content out there as well. So I can go on and on. These are two key examples that I see in the interest of time as what I can quote.
Perfect. No, thank you for that. There's an interesting follow-up question. So sometimes integrating data kills the scope of the project delivery in terms of analytics, sustainability, maintenance. So it looks like at the end is death by by data. How do you handle these situations? So who would like to take that one?
Yeah, I can take that one, Hector, and it follows on a little bit from what I said earlier on. You know, we were talking about the fact that you know, you can get data, and we're very good at getting data from different silos and bringing that together. And sometimes the aggregation of that data, the integration of that data in itself is what generates insights which previously weren't, you know, being able to put together or be able to put together you know, fast enough. But it's really key, as we said, to identify what the use case is and the problem that you're trying to solve, and then select your data appropriately for that. You know, if you just go out and look at the data that's there and try and mine it for value without having that you know, business value proposition in mind, then you can find yourself, you know, just wrapped up in integration of data and connectivity issues. It's really important to have a well-defined use case and what a successful business value would look like, and get your data accordingly for that.
Thanks. We may have time for one or two questions, one or two. This one is a follow-up question about the use of AI. The question is, I come across the problem of cost of AI doesn't match what we can get out. So argument, can you show that AI is worth the investment? It's interesting because, you know, we may think that AI is the cure to every problem in the industry, but here they are challenging this. So who can take that question about, you know, can AI be, you know, worth the investment?
I can take that one. So yeah, finding the right use case, and you know, AI covers many different things. I mean, we just talked about vision and sort of batch control, two completely different fields of AI. And you know, the difference in cost can vary. I mean, you can now get sort of some vision AI technology that plugs into a phone and can use the camera on a phone and can be very cost effective. Or you can go with one of these end-to-end sort of AI platform providers and spend millions. So the important thing is to park the AI, focus on the use case, and do that thing. Keep it simple. You know, you don't necessarily, if you don't need AI, then use a simpler solution. The reason that you would pick AI is if, you know, AI has particular strengths in that area. Vision analytics, absolutely. If you're analyzing time series data, I still think AI's got some challenges on time series data. Predictive maintenance, it's excelled there, but in other aspects of it, there can be challenges, and those challenges cost money because the projects take a long time to resolve. So getting good sort of feedback from you know, people that have done this before is also good to judge how much something's going to cost.
If I can add one sentence or a couple of sentences to Paul, real quick, 30 seconds. I do agree with that. I mean, by the way, it's a great question. And everybody has to do their homework on putting a cost-benefit analysis up front and then continue to improve upon it, right? For example, you cannot just say, I spent so many dollars and within 3 months, I didn't get the output. It depends on the duration of time, your goals. You got to, that is where the investment has to happen up front to come up with a good business problem statement and the outcome you're looking for. So like Paul said, every use case is slightly different. And that analysis is the onus on the people who are leading that exercise.
Yeah. And I think I'm gonna tap on you guys for at least one more question here, which because I think is a nice follow-up to that previous question about the use of AI. So assume that I really convinced I see the value on AI. The question here is, so what criteria are typically used to select the right partner for my AI solutions? Because the reality is that partners, there are many, and there are many more growing. Every day there is a new AI startup coming up to the market. So how, you know, what advice do you guys have to companies that need to select the right AI partner for their projects? Who would like to take that one?
So if I could be very quick on that, I would say focus on the use case first. If you pick an AI, if you pick an AI partner, then you're putting the technology first. And then you'll have when you've got a hammer, everything looks like a nail. Look for your solution partners, and then when AI is needed, then you can look at the AI partners that are mapped most closely to your requirements.
Yeah, I'll add my 30 seconds to that. That's a great question. Once again, when you put together a team, either it's made up of your own people who you employ or your partners or contractors, it's very hard to do it. But what you got to do is a person who has a combined skills of the domain knowledge and be able to do the data analysis. If you have the data analyst, the data scientist, the data engineers on one hand, the subject matter expert on the other, you'll always end up seeing the same thing through different lens, and you end up having that gap coming along the way. Some people just purely look at the data and some look at it from a use case. So it's hard to find those kind of skill sets in the market. But if you have people, for example, is a civil engineer or maybe a mechanical engineer, but then figured out how to become a data scientist, if you bring in one or two people into your group of that kind who can think both together, I think that will add a significant difference.
Yeah, and Hector, just let me add one piece to that. I mean, I think there's many companies out there, have done successful pilots and successful scale-ups. I would encourage people just to look for those companies that have got good references, in similar kind of environments. I mean, I hear what Paul said about the challenge of AI and time series data. I would argue with that and say that we can do a pretty good job and do that every day with AI on time series data. So it's really important to find a good partner who's in the domain where your problem is that needs to be solved. I wouldn't rule out new startups because of references, because there's some fantastic innovation coming through those new startups. But certainly where there's many successful examples out there, absolutely, try and find a reference that lines up with something similar to your business is what I would suggest. Perfect,
fantastic. Well, I really appreciate it has been a great session today, great panel. I want to thank Gary, Paul, Gary, and Srinivas, our speakers today, for their amazing insight and knowledge during this panel discussions. This concludes this panel. And in closing, I'd like to thank again our sponsors, Hitachi Vantara, HiveMQ, Siemens, Fortinet, Keyfactor, EMQT Technologies, K-Factory, OVCMDT, Trend Micro, Faircom, Nozomi Networks, Limbe CMMS. Oh, by the way, you may be seeing there a poll. Feel free to rate the session. Limbe CMMS, $8, and Raven. Your support ensures that we all can have these great contents to share. Thanks to all of our attendees for listening and for your great questions today. We will answer all the questions offline because we had many great questions, by the way. And now it's time to move to the next session called Achieve Industrial IoT Outcomes at Scale. Thanks again to our speakers and to our attendants. Have a great day and goodbye.